Okay, here's the question that's been bugging me. Why does every time I work with Bitbucket, I have this feeling that I click way too much? I mean, GitHub has their CLI, GitLab has CLI, but what about Bitbucket? Well, I guess you know the answer. And I enjoy building stuff, but not clicking. So I built, well, vibe coded kind of, something to fix it. And you know what? While working on it, I think I discovered one technique that, in my opinion, is way more interesting than the tool itself. So, here is my typical Tuesday afternoon. I finished working on some feature and I need to create a pull request. I will push my changes, and luckily it will show this little URL over here that I need to copy paste. Well, maybe not as little. Then I navigate to Bitbucket UI, and I would usually have a pull request template that I need to manually fill in. And very often copy pasting from commit messages. And of course, I need to make sure I am targeting the right branch. And then, when it's finally time to merge, guess what? I have to make changes again. There is no such an option in Bitbucket to pre-populate pull request commit message. And don't even get me started on release flow. I need to create a release branch, copy-paste changelog, then merge and copy-paste again, then sync develop branch after release, which is just another copy-paste cycle. Okay, so on a recent project, our team was doing a huge bunch of manual steps for each PR and every release cycle. We were spending more than 30 minutes a day on a stuff that should be completely automated. Well, with GitHub, this is already solved problem. There is GitHub CLI, and this is not to mention official MCP support. But with Bitbucket, well, Atlassian announced their MCP server, and I already tried it. Unfortunately, Bitbucket is not yet there. So today, I am gonna show you a Bitbucket MCP tool that I built to make work of my team a bit easier. So keep watching. So, here is what I built to solve this. The Bitbucket MCP server. It is completely free and open source on GitHub. I built it with Go and used a structured vibe coding approach that I already mentioned. Let me show you what this thing can actually do. So here you can see a list of MCP tools that are currently supported. This alone can already cover all the manual steps I was doing before, and even more. See those PRDiff, divstat and PRComment tools. You can actually use those and ask LLM model to do a PR review for you with a single structured prompt. I will probably record another video just about that. Now for the setup. It is pretty straightforward, but has two main parts. First, you need to configure the MCP server with authentication. I didn't add OAuth support yet, so you'll need to go to Atlassian and create access token. There is a full guide over here, but in short, you pick a token type, select required scopes, and that's it. You have your token. Make sure to convert it to a basic format with this script. You will need your email here. Once you have your token, you can start the MCP server locally using Docker or Docker Compose. I've got a pre-built images publicly available, so it's literally just Docker Compose up and you are running. And finally, configuring your AI agent to connect to the MCP server. The tool supports both streamable HTTP and server-sent events. It also supports STD-IO, but I haven't tried that in action. I prefer HTTP-based transports most of the time. Don't even know why. Typically, you will have a configuration similar to this. But please review the documentation for your particular AI agent, just to be sure. One important feature The tool supports multiple accounts, so you can have your user account and, let's say, a bot account. I'll show you later how this can be useful. There is a detailed instruction to set up bot token as well. So, here is a detailed instruction on creating access tokens for the bot account. But in short, you need to go to Workspace or Repository Settings, go to Access Tokens, create new token with appropriate scopes, and then just go to a tool config and use it as a bearer token. No extra encoding is required. Let me now show you how I use this tool. So, I created a structured markdown prompts for the most common workflows. We'll leave a link in the description. And now I can feed the LLM with precise, repeatable instructions. Let's see how it works. So here is my first one. Create a pull request and automatically populate all the details required. Have a look at what happens when I run this instruction. You can see it's automatically checking my commits, following the PR template, populating it with context, and creating the PR. No more copy-pasting or figuring out what to write there. Well, for the most part. Let me also show you my release preparation prompt in action. You can see it's creating a release branch, formatting the changelog, preparing the release PR following the template. This used to take like 10 minutes of manual work, and now the LLM is doing it for me fully autonomously. And remember I mentioned official Atlassian MCP. So you can combine all this with Jira and Confluence tools, and you can do some really cool stuff here. For example, when creating a release PR, you can automatically update all the Jira tickets with the release version. Create a release summary Confluence page, or any other thing you need. Atlassian has a detailed guide on how to set up their MCP. We'll leave a link in the description as well. And for sure you can do a traditional approach with shell scripts or Python for all of those steps as well. However, we all know what's happening with those scripts after a while. They tend to become unmaintainable and nobody knows how they work. And it's usually very easy to break. With this approach, you have a plain English instruction that anyone can understand and update easily. Let me show you how it works. So, I have this prompt to merge the release. The process involves the following: merging the release PR, updating all the Jira tickets related to the release with the release version, and transitioning them to done state. You can obviously customize this part as needed. Then, synchronizing the develop branch with main. And here is where the bot account that I mentioned earlier is used. It is approving the PR, so you do not have to chase your teammates for approvals. This was another quite tedious part of our release process, and now it's fully automated. And when I run this instruction, you can see what happens. It is merging, then it's going through each ticket and updating it as needed. And finally, it is creating and approving the sync PR, all completely automated. The beauty of those markdown instructions is that they are very easy to understand and support, as well as share across the team. Now, let me finally show you the technique I mentioned in the beginning of the video. We all know how to end test our work with traditional approaches like Postman or Playwright, for example. And we all know how complex and challenging those tests can become over time. My initial plan was to actually use Playwright to test the entire Bitbucket MCP server I built, but it's not going to be a true end-to-end in this case. And you probably guessed where I am going with this. Yes, you can just use prompts to test the entire set of MCP tools with actual AI agent running those. This is exactly what I did, and let me show you how it works. Here is my test prompt. You can see it is already quite large, but it's all plain English. Let me just show you how this PR creation and updates test runs. You see, it's creating a new branch, making changes, creating a PR. Then it's checking if pull request details are correct, doing some updates, approving merging, and finally doing a cleanup and reporting. This is a true end-to-end test with real data, and it's driven by natural language. What's amazing is that these test prompts are self-documenting. A new teammate can read the prompt and easily understand what we are doing here. Try looking at 300-line Playwright script. How long would it usually take you to understand what it is and how it works? Especially if you are not a Playwright expert. Alright, so what's the real takeaway here? It's not just about building another MCP server. Yeah, it was cool to build it and I enjoyed the process. And I'm also happy to see that the Go ecosystem is catching up with all the AI stuff. LLMs are not just your coding buddies. They are incredible tools for automating repetitive tasks, and MCPs are your best friend for this. Stuff that we used to do with bash scripts in the past can now be done just with natural language. And this is way easier to understand and maintain. Many companies and organizations are realizing that, and you can see new MCP integrations emerging nearly every day. You can also quickly wipe code missing MCPs that can help you with your workflows that are part of your daily routines. A few gotchas to watch out for. Remember that LLMs are non-deterministic. Some prompt may produce slightly different results, even with the same model, not to mention different ones. Test how each particular prompt performs with a given model and then commit to using it. The MCP ecosystem is still young, so expect some rough edges. For example, I had to change slightly parameters for one of the Bitbucket tools to make it work in Cursor. And I think that's it for today. I'd love to hear your opinions and stories in the comments. Also, please help me to pick the next video. I am thinking about covering some wipe coding strategies I used to build this MCP server. Or maybe a deep dive into the Golang backend template that I used as a base for this. Drop your comments and thanks for watching.